Hi fellow enthusiasts, welcome to my channel. Let's go into today's video and we're gonna come back at the end to wrap it up. In today's video, we're gonna be looking at the passive infrared sensor, otherwise known as the PIR sensor or motion detector. From the name passive infrared, it implies that the transmitter is not powered. So the signals that it receives is coming from sources that are not powered. Like any human being or any living thing emits some infrared signals. Fresnel lens here collects all the rays of the infrared signals and concentrates it on the sensor right here. You can see there's a metal shield around it that helps to improve temperature and humidity. Now, the sensor has 3 pins: the positive, the negative or the ground, and then the signal pin at the center. Right, so when this sensor detects changes in infrared signals around it, it will turn the signal pin high. Right, so we're going to show you in the code how we're able to use this and the changes we made, because we're keeping the same modules as before. We're keeping the Nextion editor, we're keeping the ultrasonic distance measure, and we're also keeping our servo motor that opens and closes our doors. Let's demo it and then we'll go into the code. So as I come close, the door opens, and then when I go further away, the door closes. You can see the same messages displayed on the screen telling you that someone is at the door. Never mind, they are gone. And then I'll show you also on the NodeMCU, there's a light that goes on and off. So when someone is there, the light is on. When someone is not there, the light goes off. But the light comes quickly back on, and I'll tell you why. I'll show you that in the code. Alright, so let's go to the code and then we'll come back and demo it one more time. Alright, so in our code here, we've made a few changes. We've included the sensor pin for pin 13, GPIO 13 or D7. This is D7 in the NodeMCU. Alright, and then we declare this integer. This is the sensor signal that comes in from the PIR sensor. So let's look at the void setup. In our setup, we've declared the PIR sensor pin, the sensor pin, we've declared it as our input, and then in the void loop, we've commented out the distance measure from the previous ultrasonic sensor, but we have included a new function, the motion detection. I'll show you what happened to the distance sensor or the distance measurement. When you go down to further down at the bottom of the code, we've included this void void motion detection. So this is a new function here. Here is where we detect motion. We read the sensor signal, the sensor pin. If the digital read returns a high, you can see this logic here. If it returns a high, then start to measure the distance. We don't want to measure the distance if there's no motion, if there's no movement around the area. So even if someone is at the door but didn't move for a while, then it is assumed there's nobody there. When there's a motion, then the door can move. Alright, so when we detect motion, then measure the distance if they are close enough to open the door or not. Then we can print out this information and we turn on the light, so if it's dark so they can see. We can include another sensor to check before you turn on the light, to check if it is dark enough, and if it's dark enough then you can turn on the light. So we're going to look at this in probably subsequent videos. And then if there's no motion detected, of course, turn off the light, and then we can declare no motion detected. But this will print forever. It will print indefinitely. So we don't want to do that. So we just commented it out. We used it for debugging. All right, so that's it. So let's go back to the demo and see how this functions. I want you to pay attention to what's going on the screen. So when a motion is detected, let's zoom this out. So when motion is detected, you can see on the let's make this more visible. Alright, so when motion is detected, the serial monitor prints out motion detected. So you can see that as I move, it prints out motion detected. Now when the motion is detected, then my proximity will be sensed. So if it tells you someone is at the door. If it is less than 10 centimeters, you can use any distance you want. And then the door is closed again, and let's stay still for a while and see what's going to happen on the motion detection. As you can see, no motion detected, and therefore you don't see anything printed out on the screen. Now I'm gonna go and try to check the distance. See, it doesn't sense the distance, it doesn't open the door. I'm gonna try to move around. And when I move around, you can see the serial monitor is printing once again. Now I can check. You can see the servo motor moves. Alright. Measure again. Okay. Now I'm gonna keep still for one more time. Let me make sure my hand is close to the sensor so I don't make sudden movements. Alright. Yeah, so even though I'm close to the sensor, nothing happens. So if I move around, move my head, now I can sense my presence. Alright. In the next episode, we're going to look at multiple sensors. We're going to look at light, sound, and touch sensors. We're going to use them to try to achieve the same functions. And then, of course, you know what we're going to do with the light sensor already to detect if it's dark enough for us to turn on the light, right? So we're going to look at this in the next video. And we're going to have multiple sensors together in that video, of course. So that will be the last video in this series, and if you have any question or comments, or if you want us to make any other video for any sensor, you can let us know in the comments, and we'll do our best to make that video. We're going to make the codes available for anyone who wants, so you can write us in the comments, and we can provide you the codes if you need it. And yeah, so as you've seen, we've used a modular approach to this project. We kept our original modules, we kept our Nextion editor, we kept our ultrasonic sensor and our servo motor, and of course our audio microcontroller, the NodeMCU, and then we introduced the PIR sensor today. And so you can introduce other sensors in the same way. Just write a code, go to a section of your Arduino IDE and write a function. I like to do it this way because it's cleaner and it's easy to debug. You make gradual increment in your codes, and if there is an error, you can easily go back and debug it and find what the problem is. And if something is not working, you're only working on this section, you're only looking at this section to figure out what's going on with your code. You're not looking at the entire code. The only thing we changed, to be frank, is the in the void loop we called this function, where is it, in the void loop? Right, so in the void setup we declared the sensor pin, and then in the void loop we invoked the function. So if there was any error from the previous code, we can delete this one, uncomment this guy, and then we delete this sensor we have here. And we use comments so it's easy to detect what's going on or to know why we're writing what we're writing. And then yeah, so you can see with this code is heavily commented. Even on the sides you have so many comments, just so that when you come back to the code at a time later, you are not lost as to why you did what you did, right? And some of the codes here we use for debugging, we had to remove after the code was functional. All right. Thanks for sticking around to the end. That'll be it from us today. Please, if you have not subscribed, do so right now, and don't forget to like and share this video. Until we come your way again with more contents, stay enthused.